Homework 8, Objective 2, how complex should the password criteria be? It's whatever. I just want to know that you understand how to check a criteria of a password. I really don't care what the criteria is. If your criteria is non-empty, I mean, try not to be that simple, I guess. So you can get some practice with checking some more advanced criteria, but as long as you're checking something, that's all me and Nick are looking for. I just want to know that you can receive a string on the server, and depending on some property of this string, you can send a different request back to the user to have some sort of server-side validation. That's what you're getting experience with on Objective 2. As far as what that verification is, like that could be a 115 assignment. Like I'm not too interested in that because I know that you all understand how to do that. If I said make sure it's an uppercase, a lowercase, make sure you have 8 of these different criteria. Like that's just more coding. That isn't really related to the concept we're doing. 220 students are probably going crazy. Is there a deadline today, Coffee and Burgers? Oh man, it's already 10:02. Time freaking flies right before a stream. All right, I gotta get going. I gotta start some things here. I thought 2 minutes sounds like so long. I guess in hindsight, no, it isn't. But oh shit, yeah. Yeah, for 116, my whole TA office hour schedule, all the Zoom links are on our Piazza. There's going to be some quiet office hours if this isn't fixed right away. If it's not fixed before I can post those links on the course website. Oh, I don't even have the links, though, do I? I'd have to collect them from all the TAs. By the time I do that, the site, Piazza should be back. Yeah, that's a tricky one. So anyone could do great. So I do want to talk about this. I actually got to talk about this in office hours yesterday. So I want to make sure I repeat it to the whole class. You, for your homework, you don't have to do any criteria checking in JavaScript. I mean, unless you're running Node and your server's in JavaScript. But your front-end JavaScript shouldn't do any criteria checking of passwords. Some sites do check criteria in JavaScript, and it's fine if you do as well. But you can't rely on that. That checking is only for the user experience. It is not for any security measure at all. Because everyone who visits your site, like I'm at this site, I can go into these sources and go into this code and edit it. So wherever you have validate password, if it's good, send it to the server. So if you have some code like this on your server, guess what somebody's going to do? True. It's always validated. No security whatsoever. This code is running on the site now. There's no change. Like I just broke things. I forget what did I just replace? Render vote. Maybe I do have to refresh this. Oh, I do have a. Going down a rabbit hole already. I expected that to not work, but I'm not going down that rabbit hole right now. The point is there are ways to mess with your front end code. So any criteria checks on the front end are strictly for user experience. So if you notice, sometimes as you're typing a password, it's telling you the strength of the password and things like that. That's just giving you a heads up as to whether or not the server is going to reject this password or not. Once that password is submitted, the server is also going to check. And that's the important one for a security measure, is checking on the server side. We have to check server side. When you get that HTTP request containing the username and password for registration, that's when it is critical to check the strength of that password. Front end, just for user experience. And the 396 exam. Malloc season. Ooh, yeah. Increments of... I don't know what you mean. Increments of 2 now. I guess any security concern. Right. And if they don't edit the JavaScript and do it like this, they're just going to send their own post requests. They can open up an IDE or a text editor, write some code that just makes a post request. You don't need, or use something like Postman, you don't need to go through the front end of a website to interact with the server for that website. You can just write your own custom HTTP requests. That's why things like HTTP only and secure, I guess is... I think that is also a browser side check in these checks for your cookies. Once somebody has your cookie, none of these checks can help you, because somebody can just set that cookie in their custom code that obviously doesn't have any browser checks because it's all your it's all your custom code. Your vote increases and decreases by 2 when you click nicer boot. Yeah, that's a feature. That's what it's supposed to be. So right now I have a downvote, but when I upvote, I'm converting my downvote to an upvote. So I went from a -1 to a +1. So I expect a jump of 2 there. If it's the first time I'm voted on something, which I voted on all these already, but if it's my first time voting, you would see the increment of 1. But once I reverse a vote, we expect that to be an increment of 2. All right, let's start looking at this thing, looking at the code, and see how this thing works. We finished the slides of Docker Compose last time, and during Q&A, we kind of pawed through the code a little bit. I want to do that a little bit more formally, though still fairly casual today. And make sure we go through this app and figure out and see just how everything is working with this thing. And also a few tips along the way. So I want to start with my users. This is probably the easier code to understand for this one. It's mostly interacting with the database, doing the hashing, and validating users. So these methods, actually functions this time. I'm used to Scala where everything's a method, so I'm always saying method. These functions are going to be the ones that will be called when users register, when they authenticate. So my app code and the other file that we'll see, that code is going to call these functions. So these are just pieces of functionality, just modular pieces of functionality. I don't have, you're not looking at the glue code to call them and put them all together right now. So let's start with a pretty simple one here, hash password, but very important and very powerful. And it's only simple because we're using bcrypt, is when I get a password that I need to hash. Either a user is registering with a new password or they're authenticating, they're trying to log in. I have a password that I need to hash. Actually, I take that back. Not when they authenticate. This is only registration because I'm generating the salt here. But when I have a password I need to protect, I'm going to generate a salt. Bcrypt has us covered there. And I want to hash that password. So bcrypt has us covered there too. So I'm going to hash this password, encode it so it's binary, so it's bytes, and generate that salt. Now what bcrypt is going to do is store the hash of this password and the salt together. It takes care of that bit of logistics of storing the hash and the salt in a database. We don't need 2 different entries in our database for that. Bcrypt is going to encode the entire thing, the hash and the salt, all together in one big string, and that's what we're going to store in our database. So bcrypt Very nice, one line, but does a lot of stuff for us. Getting that salt, appending the salt, hashing the password, and storing the hash of the password and the salt all together. Very nice, compact way of handling that part of our security. Creating a user, once I hash their password, so when somebody registers, I've already validated the password at this point. I want to hash that password using that method we just looked at and insert that into our database. So I'm going to take a users collection, which I got from my database server, access the database that I want to use, and then access the collection out of that database that I want to use. I'm using two different collections here, users and tokens, to be able to store the information that I need for authentication. Users is going to store these username password pairs, so I can know when somebody goes to authenticate, I know how to look up their hashed password and their salt to be able to authenticate them properly. So I'm going to insert each user as a record in this collection as a JSON string or a BSON. The representation doesn't matter, but we can store this in a JSON format, and I'm just storing username and the hashed password in the collection. Now when somebody comes back and wants to log in, I'm going to go back to my users collection. I'm going to point with my mouse instead of the cursor. Going back to the user collection, and I'm going to find the record for the username who's trying to authenticate. So I'm going to look up that record, and we have this nice find one method that's only going to return one record, where usually if you use find, you're going to get a collection of records. And if you get that collection, you want to iterate over it. If you're only expecting one result, username should be a unique key here, even though technically I'm not checking for that. So if you create two accounts with the same user, things are going to get a little weird. I'm going to pull that unique record. So I'm not going through a collection of size 1, checking to make sure it's size 1, pulling out the only element, and then working with it. Find one takes care of a little bit of logistics for us there. So I'm going to pull the record for this user, and if the user is not in the database, so user is going to be type none in Python if find one did not find anything, and none has a truthiness, is that what they call it? It'll resolve to false in a conditional if it's none. So if this is none, we're just going to return false and say we can't authenticate you. Else, we're going to go back to our bcrypt library, call this check password method, which is going to take the password, the hash, and the salt that it generated. The library is going to expect that same format. It's going to take that password that it generated and also the new password that it's trying to authenticate. And then bcrypt is going to do all the heavy lifting for us here. It's going to pull the salt out of this string, out of this data. It's going to pull the salt out of that, append the salt here, hash this, pull the hash out of this, and then compare the two hashes. So bcrypt is going to go through all that logistics for us with this one, again, a quick one-liner. So in 2 lines, bcrypt is able to get all of that salting and hashing done for us. It does a lot of heavy lifting under the hood there, which again, I mentioned this a few times, but again, it's kind of why I regret allowing bcrypt for the homework. It kind of defeats the purpose of the homework. I should have made you create salts and do hashing for the homework, and then for the project, say, now you can use bcrypt, and look at how wonderful life is with bcrypt. But, hindsight. Next time, they'll be generating their own salts and stuff. But this is valid for homework 8, to pull in bcrypt and do your hashing like this. And that's going to return a Boolean, whether they were authenticated or not. So in my app, I'm calling this authenticate. When somebody submits a username and password, that's going to return true or false to say whether or not this user submitted a proper password for that username and that the user is registered. Since hashing is one way, how does check password check the password? Because we didn't pass a salt as an argument. So that's what I'm saying. This bcrypt, the hash password here, is going to take a plain text password and a salt, and what it returns is the hash of that password with that salt applied and also the salt. So what this method returns is one value, but it contains the hash and the salt. So then when we give that value back to bcrypt in the check password, it knows how to extract the salt from that value. It separates the salt and hash again, and then it has all the information that it needs to be able to check that password. But it is storing the salt along with the hash from this hash password method. So, and that's one of the ways where bcrypt is just doing a lot under the hood for us. It's handling a lot of details for us. So that's how we're authenticating a user. When they register, we're hashing their password, storing username and hashed password, hashed and salted password. And when they want to log in, we're going to pull that hashed password for that username and then check against the password that they just submitted. So these three methods here, there's a lot going on here. That is the crux of authentication on the internet. When you create a user account, store a password, like this is the core of what's going on with that functionality. But that's not quite good enough for us. We also don't want users to have to continuously re-log in every time they use our app. And for that, we talked about tokens and setting a token as the cookie for that authenticated session. So this cookie, this token here, is going to say, I logged in at some point, look up this cookie, that's going to tell you who I am, and then you can treat me as that user with confidence that I authenticated sometime in the past, like we talked about in the slides. So for that, when somebody does authenticate, we want to assign them one of these tokens. We want to generate a random token, assign them that token, and then say, store that token and say, if I see this token again, I know who this is. So for this, I'm going to generate a random string of length 20. And this is for your homework where you need entropy at least 80 here. So I'm going to generate a token of length 80, and I'm going to generate a random string of length 20 using lowercase letters and the 10 digits for this. So if I look at my token, uppercase and lowercase. Because all ASCII letters. Yeah. So uppercase, lowercase, and numbers, and length 20. So I can pull up if I can find my mouse. So I can pull up my calculator. Whoa. So I can pull up my calculator. I have an alphabet of size 26 lowercase, 26 uppercase, 10 numeric digits, and I have a length 20 string from that alphabet. It's going to give me this many possible tokens, this many possible token values. And if I want to compute the bits of entropy of that, I'm going to take the log base 2. I don't have a log base 2 button, so I'm going to use my property of logs and find that I have 119 bits of entropy here. So I'm north of that 80-bit minimum. So I'm good on my tokens. Nobody's going to be able to guess these tokens. And just for some quick math, I want to do some quick math while we're in here. There's 62 raised to the 20. This is how many possible tokens can be generated, and we'll assume that these are strictly randomly generated, that I have a nice uniform distribution over this space, which is probably not true. I was going to say may or may not, but it's, in a strict sense, it's not true because these are pseudo-random number generators. But let's just do some math and assume that it is completely uniformly random. Is system random truly random? My language has a special crypto random bit generator. Yeah, I should be using, I think it's the secrets library in Python, which I should be using if I want some more true randomness, some more like cryptographic randomness. But true random doesn't exist. There's, aside from some theoretical work talking about the quantum, I almost said quantum realm, but yeah, basically the quantum realm. But at quantum levels, there might actually be some true randomness in the universe. Besides that, there's no such thing as true random. Everything's just made up. But the cryptographic random libraries at least give us more randomness and enough randomness that we're confident using it in cryptographic purposes. So that's why I'm really stressing, let's assume that this is uniformly random, because I should be using some cryptographic random library here. But assuming that, let's do some quick math and see how somebody could break this. So strictly guessing one of these tokens is going to take this many guesses, which is a ridiculously large number. 7 times 10 to the 35 is a silly large number. Decillion? I don't remember my names. I played enough clicker games that I should know this, but it's something, the one past decillion. So if you want to attack a token, you would have to have this many guesses to guarantee that you're going to crack that, which is just, it's impossible. You don't have enough computing power to do that. But that's not the situation that they're facing. The situation they're facing is if they attack a database and they have all of these tokens, they can attack all the tokens at once. Because we're not using any salting, I should probably get to the end of this part first. When I store these tokens, I'm taking the SHA-256 hash of this, and I'm not salting the token. So I store hashes of these tokens. So if you recover the database, you don't just get the raw tokens themselves. You get a hash of the token. You would have to break that hash, and these tokens have 119 bits of entropy. They're not going to break that hash. There just doesn't exist the computing power to break those things. Unless SHA-256 itself has a vulnerability that somebody finds, nobody's gonna break that thing. But that's not the situation they're faced with. They can have lots of tokens. They can have all of the tokens and try to break any of them. Or rather, more to the point, is they can go to their cookie and just enter some random value. And if that is a valid token, they are now authenticated as that person. So we have to make sure it's infeasible for an attacker to just randomly guess and have any valid token. So we're not getting this full entropy. We're actually getting this divided by the total number of tokens that exist. So let's run some numbers and see how effective that attack would be. Just going to their cookies and just trying random tokens, or rather writing a script to just try a whole bunch of random tokens as fast as their machine can. So let's assume that we're a few years in the future, or a decade maybe, and every single human on Earth is using our app. So let's divide this by 10 billion. So 10,000 million billion. And let's say that each human on Earth is logged in on 1,000 different devices. Just crazy numbers that if your app is ever that successful, but if your app is that successful, it's still going to take 1,000, million, billion, trillion, quadrillion, quintillion, septillion, 70 sextillion attempts to break that, to actually guess a random token. And if we say they can have, let's give them 10 trillion attempts per second, 10,000, million, billion, trillion, it's still going to take them this many seconds, this many hours, this many days, this many years. So over 2 centuries still, even with very generous values, every every human having 1,000 sessions and 10 trillion guesses per second. These are crazy numbers. Even at that, it's still taking over 200 years to randomly guess one of these 20-digit strings the way I'm generating them. And if this number was scary, hey, maybe even 200 years with those crazy numbers scares you. You don't think that's enough security? Now I have ridiculous proportions more security. So it's pretty easy to get secure tokens, even without signing the tokens or doing any extra work with these tokens. Now, of course, out there in the real world, you don't want to leave anything to chance. You would probably sign these tokens with some crypto keys as well. But we have so much entropy here to work with. Since we just have arbitrary entropy, it's actually not really a concern. But for the paranoid or for the very security conscious, you want to have every ounce of security you can get, you would increase this. You would sign your tokens to verify that you did issue that token. And of course, one feature you won't see in this app, a logout feature where you're cleaning up tokens out of your database. I never actually delete a token out of this database, which is a security risk. I wouldn't do that in production either. But there's just so much entropy here. We do still have to hash the tokens though, because if somebody attacks this database and just gets all the tokens, well, it's game over at that point. Doesn't matter how much entropy we have if they just have the tokens. But if they have to crack a hash with a bunch of entropy, and here we don't even have to salt either for the same reason, because we have so much entropy. Rainbow tables are ineffective. Attacking all the hashes at once, as we just saw, is ineffective. There's just so much entropy. The salt just isn't really needed here. And again, for the security paranoid, throw salt in there. It ain't gonna hurt anything. Say someone made a bot to change their password every few days. Would that help or not? Since on one hand, the attacker can already look over a password, on the other, it can go back to one the attacker didn't get yet. Somebody made a bot to change their password every few days. That can help. So if you have strong passwords and you're changing them every few days, it's really not much an attacker can do unless they're stealing your password directly. But if they compromise the database and they throw their attacks and throw all their processing power at cracking your hash, if you have a strong password, it's probably going to take them more than a few days. So by the time they crack that password, you already have a different password. And that doesn't do them any good. But I'm not sure what the rest is you're saying. Since the attacker can already look over a password, on the other, it can go back to the one the attacker didn't get yet. Oh, do you mean like cycling through a finite list of passwords? If you're always changing it to a brand new password, like you have a random password generator that always updates every few days. Yeah, if you're paranoid about your security, that's going to be pretty rock solid. If you have brand new strong passwords every few days. It depends what kind of attack they're launching. If they're just going to the site and trying different passwords through the front end, then yeah, you're gonna trip them up with that one because they're not going back to the ones they already guessed. But if they're compromising a database and trying to crack that hash offline, they're going to keep trying to crack that hash. They'll eventually crack that hash. It might be in several millennia, but they'll eventually crack that hash. But your password would be long changed since then, so it doesn't matter. So what you're protecting against there is databases that have been compromised, and that the hash and the salt of your password is in the hands of an attacker. When you change your password, you're invalidating that hash that they're trying to break offline. So that's what changing your password really gets you. All right, so we're storing hashes of these tokens, and when somebody visits our site, we're going to, when somebody authenticates, we're going to generate a token for them. Very long, very high entropy token. And, I am at least doing this. So I added one line of security. So I'm removing all tokens for a username each time I issue them a new token. So you can only have one token at a time. So I am doing something good there. Good job, Past Jesse. And then I'm inserting into this collection, this tokens collection, that username and token pair. So I want to associate this token with this username, with this user account. And I'm going to store a hash of that token, the SHA-256 hash of the token along with that username. When I do get a request, I'm going to go back to this collection. I'm going to get the token that came along with this request, if there is one. If there isn't one, just say, I don't know who this is, and pull up the token for that. So I'm going to hash this token, go to my database, and find the record with that token. If there is one, return the username and say this is the person associated with this token. So I want to get the username associated with the token that is stored in a cookie in this request. So I'm going to get that cookie, hash it, hash the value, look it up in my database, and return that username if it's in that database. Did I change anything? I think I undid all my changes, but I'll say no anyway. And finally, the app. So the app has a bit more going on, but a lot of this, the advantage here is that a lot of this we've seen before. It's not authentication specific. So I just want to highlight where we're using the authentication methods that we just looked at. So with this, I don't want to talk about this line too much, but this line is probably going to be one of the biggest headaches on my end. But that's for me to deal with. When I go to deploy your app, since I'm using a domain name, the domain name of your request isn't going to match the what am I trying to say here? The host name of your app, which at least for Socket.io with using Flask with Socket.io was blocking all the WebSocket requests. I had to add this to say, hey, even if that request is coming from tictactoe.info, please don't block it. Like, accept that connection. But this does open up. Actually, I should just change this to tictactoe.info, because this does open up a security risk. I typed in the wrong spot. You get the idea. All right, so same thing. I'm going to pull up my database server, get the database from that server, and get the collection from that database. So there are always three layers. Even if you're using MySQL, there's a database server. That's MySQL or Mongo, or if you want to adventure out to a third route. By the way, this was Nick was updating the Piazza post on this, and somebody asked in office hours, so I want to make sure I broadcast this to the class. If you're using something like Firebase for your project, should we? Don't worry about it for phase 2 stick figure. I mean, if you do, that's fine, but that's something I'm gonna have to go into and figure out when I go to deploy. If you know what's up with that, by all means go ahead, but I just expect to have to do that for every team. If you're using Firebase or something else, I did previously say Firebase not allowed, but somebody made a compelling argument in office hours. I agree with it. So if you are using Firebase, you can still use Firebase, because nowhere in any of the documentation did I say you can't use Firebase, but you do have to use Docker Compose with a database. So if your app is already set up with Firebase or some other database service, you also have to have a database using Docker Compose and interact with that database. But I am allowing you to use both databases. So if you have two databases, one of them fulfilling the Docker Compose database requirement. And that database does have to do something with your app. You have to have at least one feature of your app that uses that Docker Compose database. Because I want to make sure everybody knows how to communicate between containers and how to set up a database that way. But then if the rest of your app, you use another database service, I'm fine with that. I'm going to allow that. So you still have to have the requirement in there, but nowhere in my documentation did I ever say that you can't have a second database. So it's kind of a technicality, but I'll allow it. And to do that would be more work anyway. But the specific team I was talking to, they already have things set up in Firebase, so it would be more work for them to tear all that down and rebuild it with the Docker thing. So if you're also in that situation, if you're another team in that situation who hasn't asked about it, I just want to make sure you know that I did make that. I am allowing that. I don't understand the purpose of hashing a cookie token for validation comparison. If the cookie is stolen, it will still hash out to the same value. Is that only to protect users in the case of a database hashers being stolen? Yes, it's only to protect users if the database itself is compromised. So if the database is compromised, the attacker gets a bunch of hashes, and that just doesn't help them. They can't take those hashes, go back to the token, and then set that token as their cookie. They don't have that ability. It doesn't protect us against client-side cookie stealing. It doesn't protect us against that in the least, at all, in any way, shape, or form. Or people sniffing packets and somehow getting through our encryption. Or maybe we're just being sloppy and sending these cookies unencrypted. If we don't have that secure-only bit set, they could still steal those cookies. Storing hashes doesn't protect us at all, in the least, there as well. But only if the database is compromised. That's why we're hashing those before we store them. So even if you're using MySQL, we're connecting to the database server, Mongo or MySQL, MongoDB or MySQL. That server is going to have multiple databases. I mean, it might only have one, but it can have multiple databases. So at some level, you have to specify the database that you're connecting to. Where with MySQL, this is a bit, there are other steps involved. You either have to set environment variables, or in your connection, when you connect to it, specify the database somewhere at that level and make sure that that database is created at some point. Mongo, if the database doesn't exist, it's going to create it for us. So we get a little convenience there. And then once you connect to that database, you want to connect to the specific collection, pull the specific collection out, or with MySQL, the specific table. What table in that database are you connecting to? So each one of these database setups have these three layers. A database server that can have multiple databases, which can have multiple collections or tables. So just being aware of these different layers of the database. You connect to a server, then you specify which database you want to interact with, and then specify either the collection, pull that collection, or through your query specify which table you want to connect to. So a few things I hopefully can clear up there. I'm going to remember just the socket connections, so I can remember which username is associated with a socket, which is something you want to do for your project. You don't have to do this for homeworks, but for your project, when you get to phase 3, this is something you'll want to do for sure. And when I get a connection, I can pull the token out of the cookies when I get this socket connection. This will be different for each library. For this library, I have access to the HTTP request for the connection. I'm going to send that whole request over to my get username. And if that returned a username, then I know that this is a valid token, and I know the user associated with that. So in my sockets collection, I can associate that socket with that username. So now any future communication over the socket, I'm going to assume is from this user. So anything from that connection, since I authenticated it once, I'm going to trust that it is still that user. This we could have more security. We could be authenticating each request on the socket as well if you want more security there. But I'm going to authenticate that connection once, and then for as long as that TCP connection lives as a WebSocket connection, I'm going to trust that it is that user because the handshake came with a valid token. So that's how I have it set up here. So, and we actually saw that in Q&A yesterday. I stole a cookie. I stole my own cookie in a different window, and I have to refresh to get the socket to be associated with that stolen cookie because I'm only authenticating on connection. So, for what it's worth. I'm going to skip vote for now just because it's the most complicated one. Get images, we saw this idea before. I think we saw this, probably this exact method before. When the page first loads, oh no, not logged in. When the page first loads, I'm going to make an AJAX call to get images. And that's going to return all of the images. Oh, we have negative votes on something. Was I playing with that? I might have clicked. I must have done that. So get images is that AJAX call that's made when the page loads. It returns all of the images and how many votes there are for each image. So the JavaScript side can render those images. Uploading an image, saving the file, saving a reference to that file in the database, the number of votes, the total number of votes, and also the users that upvoted and the users that downvoted. So this is our next authentication thing that we want to talk about. So when someone votes for an image, we don't want to let them vote multiple times. We just want to send them a message and say, hey, you can't vote for this again. We're going to do that. There are different ways to do this. I'm going to do that by recording if which users upvoted and which users downvoted a particular image. So I'm going to store that right along with the image in the image collections and store those as two lists. When the image is uploaded, we're emitting on the socket and saying, hey, there's a new image. And if I have... Come on, mouse. And if I have an image that's being... Oh, not socket.io. This one. And if I have an image that's being shared... I feel like I'm losing my mouse here. I already upvoted that. So if I share an image over here, I'm going to say, I had this. There it is. I just stole an image off of this site and did it. I'm going to get... Oh, somebody else did it. So I don't have to refresh the page at all to get that new image. It just shows up immediately. So I got the WebSocket message that says, hey, there's a new image. And then my JavaScript runs in response to that message and renders that, adds that to the HTML. And then there's another request that's made for that image. As soon as that image with that source for that image is added to the HTML, to the DOM, the browser is going to look at that and say, oh, looks like I need to make another request to get this image. So we get quite a bit going on when a new message is uploaded. We get that message over the WebSocket. The JavaScript runs, adds it to the page, and then the browser makes another AJAX call to get that image to request that resource, to get that information. Oh, mobile Piazza intake. Nice. I'll make a Piazza post to the class. Use mobile if you want to read this. I'd have to install the app. Now that I think about it. So we get that interaction. And by the way, of course, we have all the nice features. This real time. If I vote here, it shows up on the other window immediately. So we have all those features that we want. And now when somebody does vote, I think the rest of this, log in and register, these are what you would expect. I'm pulling the username and password and calling the methods that we saw earlier. Setting that cookie. Secure. I changed this, but I didn't reload the site, so it's still not secure. Secure only. In my password validation, I'm only checking length greater than or equal to 8. That's the only check that I have here. But I have that check, and if that's not the case, if all of these validations are not the case, the other ones are just not a, the passwords have to match, and you can have a blank username. If those aren't all true, I'm going to have a custom message based on what went wrong, and that message is going to be displayed to the user. So if I have poor registration, if something's wrong during registration, I'm going to get one of these messages, and it's just going to be a text box. If you play around with the page, bad authentication, you'll be sent to a whole new page with just a plain text string, and nothing fancy here. I'm just returning this string to the user, and that loads as a new page, and then they hit the back button and try again. But the oh no, yes. And then when somebody votes, we're going to play around with our data structures a bit. So we're going to look up the user for this socket. If there's no user, we're going to say, hey, what are you doing? You have to be logged in to vote. Now, with the site, there shouldn't be a way for somebody to get to that functionality. They shouldn't be able to be voting if they're not logged in. But there are ways to do that by not following what the app wants you to do. And it's actually pretty easy with this one. So you can get around a lot of things, and you can actually cast a vote without being logged in. And when this happens, I still want a check here. I still want to make sure that I'm authenticating at every step of the way to make sure that somebody who's not logged in isn't accessing parts of a page that they're not supposed to. And this will be a very important part of phase 3 of your project. Everything that requires authentication has to be secured, because users can always bypass your front end and send custom requests. Somebody can make a WebSocket connection and just start casting votes. And I don't want to allow that. So if they have a valid WebSocket connection that has been authenticated, I'm going to pull up that user or that image, pull the upvotes and downvotes, and check if the user upvoted or downvoted already. And if they upvoted already and they're trying to upvote, send them a message, you already upvoted. If they're downvoting and they already downvoted, send them that message. I'm sending those messages over the socket as feedback, and then my socket, I have this feedback div right here. The socket is going to, on those messages, pull up this div and change its inner HTML to that message. So I have more dynamic messages than just sending for authentication, where I just sent them to a new page with just a string. So I have a little more interactivity there for the voting. And if it is a valid vote, update the two lists, and then go back to the database and update for that image, set the updated votes and the upvotes and downvotes to remember which users did which voting. And then let's take a look at, actually, do I want to do that? Let me actually do one other thing that I wanted to do. So one thing that I recommend for developing, especially phase 2 and phase 3, when you're developing, if you're using Docker Compose, well, you have to use Docker Compose, but when you're using Docker Compose, it can take a very long time to spin up your app, and the testing loop is very lengthy if you have a long startup time for Docker Compose. So I recommend that you set up your app to run without Docker Compose for testing purposes. So if you run either install your own database, which could be, which you can do, it's perfectly fine, it's good practice. Or if you want to stick with the Docker database, write a Docker file for your database and expose the port that you need and set any other variables that you need inside a Docker file, or even Docker Compose. You can just use Docker Compose for this as that you already have set up, and then run this container. We'll build it, run it, publish the port. If I can type, man. I didn't build it, but you get, just to show you the idea, detach and run this database, mapping its port to localhost, and then in your app, wherever you have your image name, change that to localhost, and then use this Docker database, but use it as localhost, and then just run your app as you normally would without Docker or Docker Compose. It can really speed up your feedback loops, where you can run your app real quick, have it connect to this database, and not rebuild an image in a container every single time you want to test a feature of your app. It can really speed up your process. And that's why you saw in my Docker file, the first times I was showing that, I was exposing my port and mapping that to localhost, because that's how I was testing that app. And one last thing, let's get to this part, because I like this part. Docker exec it. Oh, come on. Hit the wrong thing. Mongo. So I'm going to enter into my Mongo container by executing command. The command I want to execute here is Mongo. So I'm entering directly into the database so I can look around and see what kind of data is stored here. Usually we would run bash here. I'm just cutting out one step. I would run bash and then type Mongo and bash. Cutting out one step by doing that. And I can see what kind of data is in here. My image share database, use image share. You can see the collections and db tokens find, and I can take a look at what kind of data I'm storing in my database. So if I want to look at the tokens, I can see that I only get hashes of the tokens. So if I look at my token, so if I take my token, at this point, most of you who are left probably saw this Monday, but SHA-256. But I want to get this in a lecture video. If I paste my token, it's not my token. I'm going to get that hash. So that's exactly what's stored, exactly what we expect, is the SHA-256 hash of my token. That's what's stored in the database, and that's what we're looking up when somebody makes a request. But given the hash of a database, I can't crack the token for this account. If I could, I wouldn't even need that user's password. This is just one of my test accounts. But I wouldn't even need the password if I have the token. Password's irrelevant if you have the token. You just set your cookie to that token. Now you're effectively authenticated as that user. Then you go into, actually that wouldn't work. I was going to say go into change password and change the password right away, but passwords are going to ask you for your old password if they're doing what they're supposed to. I can look at, I did that last time too. If I look at the images, I can see exactly which users upvoted and downvoted, as expected. And we still don't have any downvotes, so everybody's pretty happy with all the uploads. And the last one that I'll be careful with, users. And the users database is going to give me the salt and the hash. This is how bcrypt stores that information. It encodes this in its own way to store that salt and the hash, the salted hash of my password, all in this string right here. Why did I get... That's weird. But that's what's stored in the password. So obviously no plain text passwords. Salted hashes only is what we're storing. In this password. I got a little. It's like my console got a little weird there.